Stanford Math Tournament 2024 problem. So we have this double sum in the limits of both the sums go from 0 to infinity. And over here we have a kind of symmetric expression, but not for this term over here. But the domain of summation is symmetric. And how do we deal with this problem? So in such problems where kind of one of the expression is not symmetric, but the domain is symmetric, what we try to do is we try to interchange the m and n and look for the expression that we get then. If we try to interchange m and n, we get sum from n equals to 0 to infinity, sum from m equals to 0 to infinity, and then over here it will again be 1 by 4 to the power m n plus m by this is just 2n plus 1, and this is just n plus m plus 1. And note that m and n are just some dummy variables. It doesn't really matter what I write in place of m or n. Both of them will gonna give us the same sum. Yeah. And now what I can do is, since these two are actually equal, I can find their averages. Yeah, and that will still be I. So basically our I will be sum of these two divided by 2. Yeah, and I'm doing that for some reasons, like you will see later on. So basically what I'm doing is, this is also I, this is also I. Now I'm gonna add these two. Let's say this is I1 and I2, and if I add these two, divide by 2, that will just be 2i by 2. So I'm just gonna get the I itself. Yeah. So we have sum from m equals to 1 to infinity, sum from n equals to 0 to infinity, and then we will add these two and divide by 2. Yeah. So what I can basically do is 1 by 4 to the power m plus n. Yeah, from their addition we will basically take this expression as common, 1 by m plus n plus 1, and then we will basically find the average of these two expressions, 2m plus 1 plus 1 by 2n plus 1 by 2. Yeah. So what I basically did is I took these two expressions as common because these were in both the sums. Yeah, and we find average of this expression. Now the real fun begins while solving this up. If you try to sum this, we get 2n plus 1 plus 2m plus 1. That's just 2m plus 2n plus 2. And dividing by 2, you see that this expression will just reduce to basically 2m plus 2n plus 2 by 2 times 2m plus 1, 2n plus 1. Yeah. And then you observe that this is just m plus n plus 1 by 2m plus 1, 2n plus 1. Yeah. And now you will be able to cancel the m plus n plus 1. Yeah. So you get sum from m equals to 0 to infinity, sum from n equals to 0 to infinity, and then 1 by 4 to the power m plus n by, now this will just be 1 by 2m plus 1, 2n plus 1. Yeah, because we will cancel this and this expression. And now we know that we can like separate the sums of m and n because they are basically the algebraically independent of each other now. So sum from m equals to 0, 1 by 4 to the power m, 1 by 2m plus 1, and sum from n equals to 0 to infinity, 1 by 4 to the power n, 1 by 2n plus 1. Okay. Now since m and n is dummy variable, these two sums are basically the same, so we will write them in 1 and then square it. Now also, how to evaluate sum? And the trick in this is we can basically try to change it to integral. So over here we can notice that this is just integral from 0 to 1 of x to the power 2m dx. This is a common technique, and because this gives us x to the power 2m plus 1 by 2m plus 1, and when it evaluated at 0 and 1 we get this expression, and we will square this, because we have two such sums. And if we now take this expression inside and it is in sum and integral, we get integral from 0 to 1, sum from m equals to 0 to infinity. Now this is just x square by 4 to the power m, dx, and then whole square. And then you see that since the modulus of x is basically going from 0 to 1, so x square also from 0 to 1, x square 4 from 0 to 1 by 4. So that means the common ratio over here will be less than 1, so that's why we can use now geometric series, infinite geometric series. And the first term will just be 1 because m is 0 by 1 minus common ratio will just be x square by 4, and then dx square. Now this is an easy thing. So now this is just 1. Okay, so first of all let me take the 4 LCM, and we get 4 over here, integral from 0 to 1 by 4 minus x square dx whole square. And so if you use the formula, we get 4 times, this would be 1 by 2a is, so since this is a 2 square minus x square, our a is just 2, 1 by 2a ln of 2 plus x by 2 minus x. This will formula is 1 by 2a ln of a plus x by a minus x, and this goes from 0 to 1, and the whole result is whole squared, and 4 and 4 cancel out, and here we will have this is basically ln of 3 by 1 minus ln of 2 by 2 is ln of 1 squared. Ln of 1 is 0, so this is just ln squared 3. And so we are done. And if you want to check the answer, you can write the sum in calculator and make the upper limit 100 or 1000, and you get the same result. I've already checked that. Now what is the flow? I first told that when there's a half symmetric expression, you can try to introduce m and n, and from there take the average. And while you are taking average, there might happen some miracles like in this case. And now since this product is independent of m and n, m is independent of n in the product, we can try to separate them and then squared, and again introduce an integral over here so that it's easy to evaluate, because you can introduce integral in sum, and that's helpful. After that you get a standard integral whose answer comes in terms of log, and you get the answer. Hope you enjoyed the video. Thanks for watching, and look forward to seeing the upcoming videos too.